Have you ever wondered about the mysterious wanderers of our galaxy? We're used to planets being tethered to a star, doing their cosmic dance around a gravitational anchor. But what about those celestial objects that play by a different set of rules? Today, we're diving into the fascinating world of rogue planets, those cosmic nomads that roam the vast expanse of space, unbound to any star. Imagine a planet, much like our own, but adrift in a perpetual cosmic night. These are the rogue planets, and their existence raises more questions than answers. Stay tuned to uncover secrets that will blow your mind. So, let's start with the basics. What exactly is a rogue planet? You might also hear them called free-floating planets or interstellar planets, all names that hint at their solitary journeys. Unlike Earth or any of the planets in our solar system, rogue planets aren't gravitationally bound to a star. They're cosmic orphans, cast out from their stellar nurseries, left to wander the interstellar void alone. They come in all sizes, from Earth-size to even larger than Jupiter. Some are shrouded in thick atmospheres, while others might have rocky surfaces, possibly even harboring hidden oceans beneath. And while they may lack the warmth of a parent star, some rogue planets retain internal heat from their formation, a faint ember in the vast cosmic darkness. Rogue planets, by their very nature, are incredibly difficult to detect. They don't emit light like stars, and they're not illuminated by a nearby sun. They're practically invisible against the backdrop of space. So, how do we even know they exist? Well, that's where things get really interesting. One of the primary ways we find these elusive wanderers is through a technique called gravitational microlensing. Massive objects, even rogue planets, warp the fabric of space-time around them. And when a rogue planet passes in front of a distant star, from our perspective, that warping acts like a lens, magnifying the star's light for a brief period. It's like a cosmic magnifying glass, giving us a fleeting glimpse of these otherwise hidden worlds. Now you might be thinking, rogue planets fascinating, but they're probably incredibly rare, right? Well, hold on to your hats, because what we're learning is nothing short of mind-blowing. Early estimates suggested there might be a few rogue planets out there, cosmic oddities drifting through the Milky Way, but as our detection methods improve, we're finding that they might be far more common than we ever imagined. Some studies suggest there could be billions, even trillions of rogue planets in our galaxy alone. It completely changes our perspective on the cosmos and raises some profound questions about planet formation and the very nature of our universe. Chapter 4. Gravitational Microlensing, our Cosmic Looking Glass. Let's dive a little deeper into this gravitational microlensing thing because it's pretty darn cool and it's revolutionizing our understanding of the cosmos. Imagine you're looking at a distant star, and suddenly it brightens for a short period, then returns to its normal luminosity. That, my friends, could be the telltale sign of a rogue planet passing in front of it, as the rogue planet's gravity warps the fabric of space-time around it. It acts like a lens, bending and focusing the light from the star behind it. From our perspective here on Earth, it's like the star is momentarily magnified, giving us a chance to detect it. A larger, more massive rogue planet will create a more pronounced lensing effect. It's like cosmic detective work, using the very fabric of the universe to unveil hidden worlds. Chapter 5. Seeing the Unseen, the Infrared Advantage. While gravitational microlensing is a powerful tool, it's not the only way we can detect rogue planets. Remember how I mentioned that some of these wanderers retain internal heat from their formation? Well, that heat, though faint, can be detected as infrared radiation, and that's where infrared telescopes come into play. These incredible instruments are designed to detect the heat signatures of objects in space, even those that are too faint to be seen in visible light. By scanning the cosmos in infrared, astronomers can potentially spot the telltale glow of a rogue planet against the cold backdrop of space. These heat signatures are incredibly faint, and it requires incredibly sensitive instruments and a lot of patience. Infrared observations can provide us with valuable information about a rogue planet's temperature, composition, and even the possibility of an atmosphere. It's like giving these cosmic ghosts a thermal fingerprint. Chapter 6. The Ultimate Game of Hide and Seek. Let's be real, detecting rogue planets is like trying to find a needle in a cosmic haystack. These elusive objects are incredibly faint, incredibly small on a cosmic scale, and constantly on the move. It's the ultimate game of hide-and-seek. One of the biggest challenges is that they don't emit their own light. Unlike stars, which shine brightly from the nuclear fusion happening in their cores, rogue planets are relatively cold and dark, and without a nearby star to illuminate them, they're practically invisible against the blackness of space. It's like trying to spot a lump of coal in a coal mine. Rogue planets are also incredibly distant. The closest known rogue planet to Earth is still many light years away, and at those distances even large planets appear incredibly small. Chapter 7. Cosmic Catapults. Ejecting planets from their cradles. So, how do planets end up as cosmic nomads in the first place? It's a question that has puzzled astronomers for years, and while we don't have all the answers, we're starting to piece together the story of these interstellar wanderers. One leading theory is that many rogue planets were once part of planetary systems, much like our own solar system, but were violently ejected from their stellar nurseries due to gravitational interactions. Imagine, if you will, a young planetary system, a chaotic dance of planets forming and jostling for position around a star. Gravitational interactions between these planets can be incredibly complex, and in some cases, they can result in one or more planets being flung out of the system entirely. These gravitational encounters can be triggered by a variety of factors, such as the close passage of a nearby star, the gravitational influence of a massive planet in the system, or even collisions between planets. Chapter 8. Born Free. The independent formation of rogue planets. While ejection from planetary systems is one way rogue planets can arise, it's not the only possibility. Some astronomers believe that a significant fraction of rogue planets may have formed independently, not as part of a planetary system. Just as stars form from the collapse of giant clouds of gas and dust, some astronomers theorize that rogue planets might form in a similar way, but on a smaller scale. Imagine a dense clump of gas and dust in a star-forming region, contracting under its own gravity. As it collapses, it spins faster and faster, forming a disk of material around a central core. These independently formed rogue planets would have never known the warmth of a parent star, destined from birth to wander the galaxy alone. Chapter 9. A Lonely Existence. The Solitary Journey of Rogue Planets. Life as a rogue planet is a solitary one. Imagine a world adrift in the vast emptiness of space, billions of miles from the nearest star, shrouded in perpetual darkness. No sunrises, no sunsets, just the faint, unchanging glow of distant starlight illuminating the desolate landscape. These interstellar wanderers drift through the galaxy for billions of years, their paths shaped by the gravitational pull of stars and other massive objects they encounter along the way. It's a lonely existence, but it's also a testament to the resilience of planets, their ability to endure even in the most extreme environments the universe has to offer. Chapter 10. Worlds of Extremes. The Surprising Diversity of Rogue Planets. Now you might think that all rogue planets are cold, barren wastelands, but that's not necessarily the case. The universe is full of surprises, and rogue planets are no exception. While they lack the warmth of a parent star, some rogue planets retain internal heat from their formation, a faint ember in the vast cosmic darkness. This internal heat can be significant, especially for larger rogue planets, and it can have a profound impact on their potential habitability. Some scientists believe that rogue planets with thick atmospheres could trap enough of this internal heat to maintain relatively warm surface temperatures, potentially even warm enough for liquid water to exist. And where there's liquid water, there's always the possibility of life, even in the absence of sunlight. Imagine a world illuminated by the faint glow of geothermal vents, teeming with life forms adapted to the eternal darkness. Outro, keep looking up. Thanks for joining us on this cosmic journey. I hope you found the world of rogue planets as fascinating as I do. If you enjoyed learning about rogue planets, don't forget to like, subscribe, and hit the bell icon for more mind-blowing space content. Until next time, keep looking up.